In this video, we'll solve this minimization problem with mixed constraints. In the past videos, we've been talking about maximizing an objective function with mixed constraints. So first, we will turn this minimization problem into a maximization problem. We'll set a value p such that p is equal to negative c, which in this case is negative 2x1 plus 2x2, so that the maximum value of p is equal to the negative minimum value of c. We have turned this problem into a maximization problem. Whatever the maximum value we get for p, we'll find its opposite, and that will be the minimum value of c. Now let's modify the problem constraints here. First inequality, we have x1 plus x2. Since we have less than or equal to, we'll just add a slack variable plus s1 equals 16. Okay, now the second inequality, 5x1 plus 3x2. Since it's greater than or equal to, we'll have to introduce a surplus variable. So minus s1, since you introduce a surplus variable, you need to also add an artificial variable. So plus, it's s2 here, minus s2 and plus a1. A1 is the artificial variable, s2 is the surplus variable, equals 60. Now let's rewrite the objective function, move all the variables to one side and leave p positive. We have 2x1 minus 2x2. Don't forget, when we introduce an artificial variable, we need to modify the original objective function. So we need to minus m times a1 here, and that term will become a positive m times a1 plus p equals 0. Of course, all the variables needs to be non-negative. So here's our initial system. Now we'll turn that into a Simplex tableau. So first, we want to turn the m in the bottom line of all the artificial variables into 0. So here we only have one artificial variable, that is a1. We want to turn that bottom m into 0, first step. So I will multiply r2 by negative m and add it to r3 and make it the new r3. The first two rows does not change, and r3 becomes like this. Now we'll look at all the indicators. And there are some negative indicators. The first two are negative. Let's pick the most negative indicator, which is negative 5m plus 2. The column with the most negative indicator is our pivot column. Now either 1 or 5 will be the pivot element. We'll decide which one is the pivot element by division. 16 divided by 1 and 60 divided by 5, which is 12. Since 12 is a smaller number, that means this 5 is the pivot element. We'll have to turn that into 1, and we'll have to turn the other two into 0. First, let's turn the pivot element into 1. So the first row and the third row does not change. We'll just have to multiply the second row by 1/5 and replace with the old R2. And this is the new R2. Now we'll change these two elements into 0. Okay, so to change 1, 0, we need to multiply R2 by -1 and add it to R1 and make it the new R1. To change -5m plus 2 into 0, we need to multiply R2 by the opposite of that, which is 5m minus 2, and add it to R3 and make it the new R3. Since R2 doesn't change here, let me write it down first. And R1 becomes like this. I'm writing down 5m minus 2, R2 on the side, and add it to R3. I will have, this is the new R3. Now let's look at the indicators again. We have these indicators, and we have one of them as negative. So the column with the negative indicator is the pivot column, and we will have to decide which one is the pivot element. After doing the division, the smaller quotient is the 10, so that means 2/5 is the pivot element. We'll turn that into 1, and the rest will turn into 0. First, let's turn 2/5 into 1 by multiplying R1 by 5/2. This is the new R1, and R2 and R3 stays the same. Now we want to turn these two elements into 0. So to turn 3/5 into 0, we need to multiply R1 by -3/5 and add it to R2. So that to make the new R2, to turn the -16/5 into 0, we need to multiply R1 by 16/5 and add it to R3. So that we'll have a new R3. We haven't changed anything in the R1, so R1 stayed the same, and R2 becomes, that's the new R2, and this is the new R3. Now let's check all the indicators. You can see they are all positive. So we're done here. We can see the basic variables are x1 and x2 and p. x1 is equal to 6 and x2 equals to 10, and p, which is the maximum p, is 8. And the rest of the variables are zeros. Since we're looking for the minimum of c, which is the negative of maximum of p, so the minimum of c is -8, and it happens when x1 equals to 6 and x2 equals to 10. And that's our solution. Hopefully this is helpful, and I will see you in the next video.